Hello class, I hope everybody's doing well. We're going to start with chapter 5 today, measurement. We're going to start with significant digits. The significant digits in a number are those that represent an actual measurement. And you use the following rules. Okay, rule 1, this is for significant digits. Whoops, significant digits. Rule 1. I'm going to give you the shorter version, but you can find this in the book too. Digits other than 0 are always significant. Digits other than 0 are significant. Okay? Rule 2. Rule 2 has a couple of options. A 0 is significant when 0 is significant when. It's significant when A, it appears between two significant digits. Between two significant digits. I'm going to shortcut a little bit of that. B is at the right end of a decimal number. And I'm going to show you some examples of this. C, marked with an overbar. So like 3.000 and an overbar. Okay? Rule 3. A 0 is not significant when A at the right end of a whole number or B at the left end of a number. So the right end of a whole number or left end of a number. So let's look at some examples. So a tachometer reading of, okay, so example 1. A tachometer reading of 84.2 RPM. Now how many significant digits is that? Well, it has 3. Why? And that's due to 1. Digits other than 0 are always significant. So 3 significant digits. Digits other than 0 are always significant. So what about a voltage reading of 240 volts? That has a 0 at the end. That is 2 significant digits. Okay, so why is it 2? It's 2 significant digits from 3A. 3A said is at the right end of a whole number. So at the right end of a whole number. So there's only 2 significant digits. Those 2 are only ones that matter. What if we had something like 240 volts, but we have an overbar over it? Well, that's rule 3A. No, I'm sorry, 2C is marked with a significant overbar. A 0 is significant when it is marked with a significant overbar. So that's going to be 3. Okay, what if we had 24.0 volts? Okay, well that's going to be 3 significant digits. Well, why is that 3? The 0 is after a decimal. That's going to be 2B, rule 2B. A 0 is significant when it is at the right end of a decimal number. Right end of a decimal number. What if we had this one? 0.025 amps. This is current. What is it? Well, it's going to be 2 significant digits. Why? Rule 3B is at the left end of a number. At the left end of a number. Okay? The left end of a number. So that's rule 3B. So that's kind of how that works. Now what about, that was significant digits. What digits matter? Now the precision of a measurement number is indicated by the place value of its rightmost significant digit. Okay, the precision of a measurement number is indicated by the place value of its rightmost significant digit. The accuracy of a measurement refers to the number of significant digits it contains. So the accuracy would be to 3. Okay, we'll look at that in just a minute. So let's look at some examples. I always do better with examples. So if we have, state the precision and accuracy of each of the following numbers. So what if we had 34.1 pounds? So that's going to be the precise precision of a measurement number is indicated by the place value of its right most significant digit, which is here. So what is its precise to the nearest tenth? Because look, it's after the decimal, tenth of a pound. Whoops. Tenth of a pound. Okay? And it's accurate to what? 3 significant digits. Because there's no decimals, and there's 3 digits. 1, 2, 3. Okay? What about this one? 0.568 pounds. This one is going to be, we're looking at this value here, tens, hundreds, thousandths. So it's going to be precise to the nearest thousandth, TH, of a pound. And it's also got 3 significant digits. Okay? All right. I don't know why it always puts these extra little marks in there. All right, what about this one? 2,735 pounds. Well, that one is going to be to the nearest pound because that's ones, tenths, hundreds, thousandths. So it's going to be to the nearest pound. And how many significant digits? 1, 2, 3, 4. 4. This one's a good one. What about this one? 400 pounds. Okay. So we have 2 zeros here. So it's going to be precise to the nearest 100 pounds. And it's only going to have 1 significant digit because these 2 are zeros at the end of the number. Okay? So that's how that works. Now, what about 10 technical? What if we had technical numbers we have to round? This is where precision, accuracy, significant digits matter, especially in a quality control type environment. So if you were working in industry and you were working in quality control and you took a bunch of measurements, you would need to know, and you have decimal points, right? So you need to pick the tolerance, the accuracy, and the significant digits to what you're looking for. So for instance, often technical measurements and numbers shown in drawings and specs have a tolerance attached so you will know the precision needed. So you've seen probably in several things it's plus or minus 10%, plus or minus 5%, plus or minus 0.5%, things like that. That's the tolerance, okay? And this will tell you how precise you need the number to be. And depending on what you're doing, you need it real precise or you need it not so precise, okay? So you always round a sum or a difference to agree in precision with the least precise measurement being added or subtracted. So for example, if you had these values, 4.1 seconds plus 3.5 seconds plus 1.27 seconds. Now notice you have 2 here, but you have 3 there. So the way you need to do that, you need it to round to agree in precision with the least precise number in the calculation. So first do the addition. So line everything up with the decimal place. 4.1, 3.5, and 1.27. And add all that up. So you get 8.87. And these are seconds, by the way. That's going to be important too. Always use your units, okay? So we got 8.87, but notice we have 1.27, 3.5, and 4.1. So we have 2, 2, and 3. So you need to round to agree in precision with the least precise number. Least precise number. Our least precise number is 4.1 and 3.5. So when we added this up, we got 8.87 seconds. So we need to round that to the least, to the nearest tenth, because that's tenth and hundreds. So we're going to, when we round that, we look at the number behind it, 8.87. That's going to round to 8.9 seconds. And that's going to be our final value. Okay, so let's look at another one. What if we have this example? 4.6 gallons plus 2.145 gallons. Again, we line it up. 2.145 gallons. So this is gallons and that's gallons. When we add that, we get 6.745 gallons. We notice we have 3 significant digits there and we have 2 here. Okay, so we're going to round that up to 6.7 gallons. Okay, so on the test and things like that, you will need to know where you need to round that and so forth. Okay. The next thing we're going to look at is multiplication of measurement numbers. Multiplication and division of measurement numbers. Okay? So to multiply, let's say, to multiply 3 feet times 2 feet. Okay? 3 feet times 2 feet. First, you're going to multiply the numeric part. Okay, 3 times 2 equals 6. Then second, multiply the units. Now when you multiply units, let me show you, it's going to be 1 foot times 1 foot. When you multiply, you square that. So it's going to be 1 foot squared or 1 square foot. Either way is correct. You can say that either way. All right. So let's look at another example. What if we had 2 inches times 3 inches times 5 inches? Multiply the numeric part first. 2 times 3 times 5 equals 15. And then 1 inch times 1 inch times 1 inch. And that's going to be 1 inch cubed or 1 cubic inch. Either one of those is correct. So that's going to be 15 inches cubed. And this will be 6 feet squared. Forgot to do that. Now, once you get good at this, you would just multiply it and then multiply each side. You don't have to go through all these steps, okay? So what about to divide? To divide, let's look at this one. 24 miles, this is very common, divided by 1.5 hours. Okay, so how fast am I going? If I went 24 miles in 1.5 hours, how fast am I going? So first, divide the numeric part. Okay, 24 divided by 1.5. It's going to be 16. Then second, the units. Divide the units. 1 mile divided by 1 hour. Or you might see it like this. 1 mile divided by 1 hour. Or you might see it 1 mile per hour. So this little divided here means per. 1 mile per hour. Okay, so when you do that, that's going to equal 16 miles per hour. Whew, that's slow, isn't it? I don't know about that. 16 miles per hour. I don't know if I've ever been that slow. Okay, so you always round a product or quotient to the same number of significant digits as the least accurate number used in the calculation. So let's look at that. Okay, so what if we had multiply 4.35 feet times 3.6 feet. So always round a product or quotient to the same number of significant digits as the least accurate number used in the calculation. So we got least accurate would be 3.6 of 4.35. Okay. So first you multiply the numerical part. And that's going to be 4.35 times 3.6, which is 15.66, okay? Then second, multiply the units. So it's going to be 1 foot by 1 foot. So that's going to be 1 foot squared, or 1 square foot, either way. And then third, you're going to round to the least precise number. Okay, least precise number. So I got 15.66 square feet, for instance. Okay, square feet. All right, 15.66 square feet. But my least precise numbers is 2 significant digits. Okay, so 2 significant digits, I need to round. Look at this number here, it's above 5, so it's going to be 16 square feet, or feet squared. Okay, 16 square feet. All right, so now let's talk about unit conversions. And there's lots of examples in the book, so make sure you look at the book too, okay? This is just an overview of the whole chapter. Now, on unit conversions, I will give you the unit conversion charts on the exam. So you don't have to memorize, you know, how many feet are in an inch, how many miles per hour in a feet per second, how many miles in acres. You don't have to know all that. That's going to be given to you, okay? But you do need to know how to actually do the conversions. So, for example, if I give you this, 6.25 feet equals how many in inches? Okay, how many is that in inches? So you have to know how many inches in a foot. And there's 12 inches in a foot. So you would say 6.25 feet times. Now, whatever you're trying to convert to is going to be on top of this, okay? So there's 12 inches in 1 foot. And this way, these two can cancel. So this is like 1 being there, okay? And then when you cancel that, see, you have inches left. So that's going to equal 75 inches. Okay, let's try another one. 2.1 miles equals how many yards? So how many yards in a mile? 1 mile equals 1760 yards. And again, I would give you that on the test, okay? So if we had 2.1 miles times 1760 yards for 1 mile, we cancel that, and that gives us yards left there, and that's going to equal 3696 yards. Now, there's supposed to be a D there, but it's not really letting me put it there. We need to convert that, and look, we have 2.1, so we need to change that. Well, so we're going to round that up, so you need 2 significant digits, so that's going to be 3,700 yards, because that's 2 significant digits, okay? Same thing with the one above it. We have 6.25. Actually, that one came out to be 75, so you wouldn't change that, okay? Let's do another example. What if we had 4,800 acres and we want to find square miles? Again, you would have to know that there's, in 1 square mile, there's 640 acres. And I'll give you these, I'll give you like a big sheet of conversions for the exam, okay? So that's going to be 4,800 acres times 1 square mile into 640 acres. So this one we're going to divide. That cancels, and you get 7.5 square miles. Okay? All right, now what do we do? These have been straightforward conversions, but what if we have something like this? What if we have this example? 98.5 feet per second equals, and we're looking for miles per hour. So in this case, we have two conversions, but you can put it all up there. So we have 1 mile equals 5280 feet, but we also have 1 hour is 3600 seconds because we have miles per hour and feet per second. So we have to do two conversions in one. And how you set that up, again, you still want to set it up where you cancel out what you need to. So feet per second. And let's do it like this so you can see it better. Let's do it 1 second times 1 mile over 5280 feet. Now notice that's going to cancel feet times 3600 seconds in 1 hour. So feet are going to cancel and seconds are going to cancel. And now you have miles per hour left. So you say 98.5 divided by 5280 times 3600. When you get that, you get 67.2 miles per hour. 67.2 miles per hour. So you have two conversions in one. So be careful on those and make sure that you set those up correctly, okay? Now, some of the other units you might have are called metric units. And in industry, they use a lot of metric units, okay? Again, I'll give you all the units that you'll need. But some examples of metric units would be 1 centimeter equals 10 millimeters. Or 1 meter equals 100 centimeters. Or 1,000 millimeters. So these are just examples of meters or metric units. Okay. So let's look at an example. So if we have this, if we have 100 centimeters is equal to 1 meter, and we had a problem like 348 centimeters, and we want to convert that to meters, one thing you could do is divide by 100, or you can just shift the decimal place 2 places. So if you have from centimeters to meters, you could just move the decimal place 2 times. So 348 centimeters would be the same as 3.48 meters. All right. What about this one? 4,500 milligrams equal to grams. 1 gram is equal to 1,000 milligrams. So in this one, that's going to be 4,500 milligrams times 1 gram is 1,000 milligrams because we want to convert to grams. So these two cancel. Now it's going to be 45 into 1,000. So that's going to equal 4.5 grams. Okay. The next unit will be convert 0.0062 kilograms to milligrams. So in this case, there's not one to go straight from that. So you need to use two conversion factors. So 1 kilogram is equal to 1,000 grams, and 1 gram is equal to 1,000 milligrams. So we're wanting to go from kilograms to milligrams. So we set up the conversion, 0.0062 kilograms times 1,000 grams divided by 1 kilogram. Okay, that's going to take care of that part. And then the next part, so that's going to go away this. And then we got 1,000 milligrams divided by 1 gram. That's going to take care of this part. And that's going to give us our milligrams. So we say 0.0062 times 1,000 times 1,000. So you're going to get 6,200 milligrams. Okay, they have to do a lot of these conversions in nursing. All right, so what if we had something like convert 578 milliliters to liters? Okay, so 1 liter equals 1,000 milliliters. So that's going to, oh, this should be 5780, sorry. 5780 milliliters times 1 liter divided by 1,000 milliliters. And that's just going to equal 5.78 liters. Now, what if we had, sorry about that. What if we have metric to US conversions? What if we convert 2.5 inches to milliliters? So we need to go from inches to milliliters. That conversion table doesn't exist to go from one to the other. So what you have to do is end up using two factors again. So if we have 2.5 inches to milliliters, okay, to milliliters, you're going to have to use 1 inch is equal to 2.54 centimeters, and 1 centimeter is equal to 10 millimeters. Okay, so you have milliliters. Millimeters. Okay, this should be millimeters, not milliliters. Okay, so we have 2.5 inches times 2.54 centimeters over 1 inch times 10 millimeters over 1 centimeter. So let's see. So that cancels, that cancels, that cancels, and that cancels, and that gives us millimeters left. So when we do all that, we get 63.5 millimeters. Okay. So on these conversions, you just really need to know the conversion sheet, but you need to practice these because sometimes you'll get confused if you have a two-step conversion like this. You don't know where to go. So the best thing is to write down what you need like this and then write down your conversions and say, oh, okay, I can't go from inches to millimeters, but I can go from inches to centimeters, and I can go from centimeters to millimeters. So if you write everything down, you kind of see that better, okay? Now, it was hard to put the direct measurements on here on the conversions or looking at how to read a ruler or a caliper or so forth. So make sure that you look over pages 339 to 365 on the direct measurements. And you really wouldn't have very many of those on the test, but you may have a couple, okay? Homework is listed on Blackboard, so make sure that you get that completed and be watching for Chapter 6 next, okay? If you have any questions, please come by to see me, make an appointment, and I'll be glad to help you. I hope everyone has a good day, and I will talk to you guys soon, okay?